Right, in this lesson we are learning to interpret Venn diagrams. Now you may have seen Venn diagrams are a way of describing data in a very visual way, and what it does is look at categories of people. And so in this case we've got categories of students at Padua who have done particular sports or co-curriculars outside of classrooms. So we've got volleyball, rugby and debating. Now if we have a look at where the circles intersect or join, we've got kids who've done rugby, we've got kids who've done debating, but we've also got kids who've done rugby and debating. Alright, so these kids have done both and they fit into the intersection between those two circles there. If you have a look at this group of kids here, 3, that means they actually fit into all 3 categories. They've done all 3 co-curriculars. Right, so we need to learn to interpret them, and then from there we need to figure out the probability of different things occurring. So if this was my survey of kids, the first thing we need to do firstly is determine the total number of students. Now that is quite simple because all we need to do is add up all the numbers on the Venn diagram. So I like to start with the outside ones and work my way in. So 60 plus 24 plus 9 plus 8 plus 11 plus 6 plus 3. So we have a total of 121 students that were surveyed. So like I went out into the yard and asked them if they'd done these things. And we need to have a think firstly about the number of students who did, say, rugby. All right, let's have a look at the rugby circle, and that is everything encompassed in this circle. Even though it's nice and easy to go, oh, well, rugby's got a 60 next to it, unfortunately we have to consider these people as well. Just because they did rugby and volleyball doesn't mean they didn't do rugby. So to figure out the total number of kids who did rugby, we need to add all the numbers in the rugby circle together. Right, so I've mostly covered the other ones. Let's have a look. We have to go 60 plus 6 plus 3 plus 11. So we have a total number of students who did rugby of 80. Right, the students who did volleyball, let's have a look. We have to we have to cover up everything else and just count the ones in the volleyball circle. So 24 plus 8 plus 3 plus 6 gives us 41. And the number of kids who did debating, same thing, we cover up every other one and just look at this circle. So we've got 9 plus 11 plus 3 plus 8, and that will give us a total of 31. So we've got our totals ready to go, and that will help us do our probabilities. Reminding that our probability of an event formula is equal to the number of successful outcomes divided by the total number of outcomes. Alright, let's have a look. The number of kids who did rugby in total. Let's have a look. Okay, the number of kids who did rugby, remember, was all this circle, which we totaled to be 80. So that means 80 out of a total number of 121 students, which is 0.66, which is approximately 66%. Now, I've done something wrong there because I haven't actually written the formula. I'm going to not do that for the sake of speed, but you need to, okay? So really quickly, successful outcomes divided by the total outcomes. Let's have a look. At least 2 of these co-curriculars. Who did at least 2? We've got kids who did 2 here. They did debating and volleyball. We've got kids who did 2 here and here, but these kids also did 2. They did 3, but it says at least 2. So our totals have to be 11 plus 6 plus 8 to get all these kids in this section, and then plus the 3 kids who did all 3. Now total is 121. So let's add them all up. 11 plus 6 plus 8 plus 3. 28 divided by 121 will give us 0.23, which is approximately 23%. Okay, let's keep going. Volleyball only. So here's our volleyball circle, but you can see these kids actually fit into other categories. They did other things. So these are the only children who did volleyball only. So our number of successful outcomes divided by our total outcomes will equal just these kids. 24 out of the total 121. 24 divided 121 is 0. Let's round it 2, which is approximately 20%. Okay, let's keep going. Now this is where things get tricky, and I've highlighted some things here because I need to point out how important the words or and are. All right, let's have a look. I'm looking for students, so our number of successful outcomes divided by our total outcomes. We are looking for successful outcomes of students who played volleyball or debating. So, volleyball, this circle, debating, this circle. Sorry. Let's hide these rugby kids because everybody else played either volleyball or did debating. These kids fit into the rugby and debating circle, but they did do debating. These kids fit into the rugby and volleyball, but they did do volleyball. These kids fit into all three, but they actually did do both of those things. So if it's or, we get a choice of anyone from this circle or anyone from that circle. So that means we have lots of options. The volleyball kids, so 24 plus 6 plus 3 plus 8 plus the debating kids of 9 plus 11. Did I get all of them? 1, 2, 3, 4, 5, 6, 1, 2. Yep, okay. Divided by our 121. So 24 plus 6 plus 3 plus 8 plus 9 plus 11 gives us 61 divided by 121, which is 0.5, which is approximately 50% there. Okay, now let's move across to this one because we are looking for successful outcomes. Whoops, sorry. We are looking for successful outcomes of people who played volleyball and did debating. It's not or anymore, it's and. They have to have done both. So volleyball and debating, it's where these two circles intersect, and that happens here, right? At this section here, volleyball and debating, they fit into both circles. So we've got a 3 and an 8 divided by our total. So that's 11 divided by 121. And we've got 0.09, which is approximately 9%. So it's very important that we understand the difference between the and the or. And I want you to say things out loud. I'm looking for students who played volleyball or debated. Okay, so there would be these groups or these groups. The and is a little bit more exclusive. Do you fit into both groups?